Every day we walk past ponds, puddles, streams, and pools of water without giving them a second thought. To us, it's just water. But what if I told you that inside one bottle collected from the top of a hill lives an entire microscopic ecosystem? Today, we are going to discover a mysterious creature that looks like a tiny tadpole, except it isn't. And what's even more fascinating is this tiny animal is carrying microscopic passengers on its own body. By the end of this video, you will know what this creature is, why those microorganisms are attached to it, and why this tiny world is far more important than most people realize. So let's begin. Last Sunday, I went trekking. As I reached the top of the hill, I noticed a small pool of still water. At first glance, nothing seemed unusual, but when I looked closely, I saw dozens of tiny creatures swimming rapidly through the water. They looked like miniature tadpoles. Naturally, my curiosity took over. So I collected a small sample in a bottle and brought it back to my laboratory. At that moment, I had no idea what this bottle contained an entire hidden ecosystem. Back in my lab, I carefully poured a few drops of small sample into a petri dish. Even under normal light, these creatures were barely visible. Using a pair of fine forceps, I carefully isolated one specimen. While transferring it, I think I accidentally damaged part of its body. But fortunately, it was still alive, allowing us to observe many fascinating details under the microscope. And this is what appeared under the microscope. At first glance, it resembles a tiny fish or a tadpole, but it is neither. Based on its body structure, this appears to be the larvae of a non-biting midge belonging to an insect family called Chironomidae. Although the adult insect resembles a mosquito, it does not bite humans. Most of its life is actually spent underwater as a larvae. These larvae are extremely common in ponds, lakes, streams, and mountain pools, where they feed on algae, bacteria, and decaying organic matter. In fact, they play a vital role in maintaining healthy freshwater ecosystem. Now, let's take a closer look at its anatomy. At the front is the hardened head capsule. Unlike the soft body, this region is heavily reinforced to protect the feeding structures. On each side are the developing eye structures. These are much simpler than the compound eyes that the adult insect will eventually possess. At the front are the mouth brushes and mandibles. These structures continuously scrape algae, bacteria, and tiny particles of organic matter from nearby surfaces. Just behind the head lies the thorax. Although it doesn't look very special now, this region will eventually develop into the muscles that power the wings of the adult midge. Most of the body is made up of segmented abdominal section. These flexible segments allow the larvae to swim with its characteristic wiggling movement. Notice the long hair-like structures extending from its body. These are called setae. They help the larva detect water movement, improve balance, and increase sensitivity to its surroundings. Running through the center is the digestive tract. The dark material inside is most likely recently ingested food consisting of algae, bacteria, and organic debris. Watching this under the microscope actually allows us to see what the larvae has been eating. At the rear are structures used for gripping surfaces and helping the larvae anchor itself among plants, rocks, or sediments. After some time, I noticed something even more fascinating. Tiny, transparent organisms were attached to the surface of the larva. At first, I wondered whether they were parasites, but they aren't. These are most likely colonial ciliates, probably belonging to the genus Epistylis. These organisms are single-cell protozoans. Even though each consists of only one cell, they are capable of feeding, reproducing, responding to the environment, and performing remarkably complex behaviors. They belong to a group of microscopic organisms known as protozoans. But why would these protozoans attach themselves to another animal? The answer is surprisingly clever. These organisms are called epibionts. An epibiont is simply an organism that lives on the surface of another living organism. They are not living inside the larva. They are simply using it as a moving platform. As the larva swims through water, fresh water continuously flows past these protozoans. That flowing water carries bacteria and tiny food particles, directing it to them. Instead of searching for food themselves, they simply let the larva do the traveling. It's like getting a free ride through an all-you-can-eat buffet. Many people might confuse these organisms with Vorticella. Although both belong to the ciliate protozoans, there are some important differences. Vorticella usually lives as a single individual. Each organism is attached by its own long stalk. That stalk contains a contractile fiber. Whenever the organism is disturbed, the stalk coils rapidly like a spring. This quick contraction is one of the fastest movements seen in the microscopic organisms. But Epistylis behaves differently. Instead of living alone, many individuals form colonies. They are attached to a common branching stalk. Unlike Vorticella, the stalk of Epistylis does not contract. Epistylis commonly grows on aquatic insects, crustaceans, snails, turtles, and even fish. Based on the appearance of these attached organisms and their location on the larva, they are more consistent with Epistylis than Vorticella. You might be wondering why we should care about such tiny creatures. Because they are essential members of freshwater ecosystems. The Midge larva breaks down organic matter and recycles nutrients. The protozoans feed on bacteria suspended in the water. Together, they form an important link in the freshwater food web. Even a small bottle collected from the top of a hill contains predators, decomposers, grazers, and microscopic hitchhikers, all interacting in ways that most people never get to see. Next time you walk past a puddle, a pond, or even a tiny pool of rainwater, remember this: you're not looking at ordinary water. You're looking at an invisible world filled with tiny engineers, microscopic hitchhikers, hidden hunters, and extraordinary life. All of this was hiding inside a single bottle of water collected during one trip. If you enjoyed exploring this hidden world with me, don't forget to like the video, subscribe to the channel, and let me know in the comment section what microscopic mystery you would like me to explore next. Until then, keep looking closer, because the smallest worlds often hide the biggest discoveries.